All right, today we're going to talk about is graphing quadratic inequalities. So when you're doing this, first make sure everything is on one side of the equation in the y equals format. You're going to graph the parabola. So you find some of the important parts like the vertex, x-intercepts, y-intercepts, all the important points. So you're going to graph it, and then you're going to draw the boundary line. So it's going to be solid if it's less than or equal to or greater than or equal to. It's going to be a dotted or dashed line if it's just less than or greater than. So if you notice on the example, it is a dashed line because it is less than. And then what you're going to do to figure out where you shade is just what you've done before with inequalities, is you're going to do a test point that's not on the line. So in this case, our test point is going to be 4, 3, and we're going to plug in your x and your y to your original. And then if you get a true statement, you're going to shade within there. If you get a false statement, you shade everywhere else. Or you can think of it this way, where you shade the region down from the vertex and you shade the region up. So for me, I do the test point and plug it in. So let's get started with the first example. So what we're going to do first is just solve this to find some important points. So first off, we're going to take this and we're going to do y, but we're going to change that to 0, and we're going to make this an equal sign for now. And we're going to factor. And what I did was I took this, I factored out 3x, and then I had x minus 2 left over. I'm going to set each part equal to 0, and then solve. So I know my x-intercepts are going to be 0, 0, because x equals 0 here. And then I know my other x-intercept is going to be 2, 0, because we added 2 to both sides. All right, so I've got 2 points here I can graph. Now let's find our axis of symmetry. And our axis of symmetry is negative b over 2a. So we're just taking our negative b, and remember it's a negative 6, which makes a positive 6. And then a was 3, so we're substituting that in there. So 6 over 6 equals 1, so our axis of symmetry is x equals 1. Now that we know what x is, substitute it into your inequality. And then we're going to figure out what y is. So once we sum in that, we get y equals negative 3. Now we have our vertex. So our vertex is 1, negative 3. So we're going to graph using these points. And it is going to be dashed because it's just less than. So I did the points here for you. So your x-intercepts, your vertex, and then just make sure it's a dashed figure. Now, what we need to do is we need to figure out where to shade. So what I did is I can't pick 0, 0 because that's on the line, but I am going to pick another point that's not, and in this case I'm going to do a test point of 1, 1. So I'm going to take my original inequality up here, and I'm going to substitute in 1 for x and 1 for x and 1 for y, and then I have 1 is less than 3 times 1 squared minus 6 times 1. And when I simplify that, I get 1 is less than negative 3. Well, that's false. So since our test point was here, we're going to shade everywhere else that's outside the figure. And then that's your answer. That's your solution. All right, for the next one, you can think of this 2 different ways. You could think of it this way, you could think of it this way. But either way, we know your y-intercept is going to be negative 4 because you're looking at the c value. And then now let's go ahead, let's find our x. So to find our x, we did negative b. And remember, it's negative, and then we said 6, because I'm just using this one. So over 2a, and so we said a is negative 1. And plug that in, and you get positive 3. So now that I know x equals 3, now I'm going to substitute that into the original. And remember, it's a negative, and then you have 3 squared, so you need to do this first, and then drop the negative down. And so I get y equals 5. And so our x was 3, y equals 5, so that makes the vertex of 3, 5. So let's go ahead and let's plot our points. So I have my y-intercept of negative 4. I have my vertex here, and then to graph the other points, I just did my 1A, 3A, 5A. To graph it, so, and it is negative, so our A is -1, so I went over 1, down 1, over 1, down 3, over 1, down 5, and plot my points, and then I reversed it over here. And I drew there. And then I connected my points, and it's going to be solid because you have this line underneath it, so it includes all those values. All right, so that's how you graph it. Now let's do our test point. Now in this case, I would definitely choose 0, 0 because it's not on the line. So I'm going to substitute in 0, 0 to your x's and your y. And then when you get that, you get 0 is greater than or equal to -4. Well, that's true. So we're going to shade in the part that includes your test point. So it's going to be everything except for what's inside the parabola. And then on this page, last one on this page, is we have this problem. So what we're going to do here is we're first going to factor, set it equal to 0, and factor it out, set each part equal to 0, so I get my x-intercepts here of 0, 0, and 3, 0. So those are 2 points that I can use. Now let's find the vertex. Now here we're going to get a fraction or a decimal. That's okay. So we're still going to find x equals by substituting in the values. So I'll get 3/2 or 1.5. And then once I've got this, I'm going to plug that in to your original equation for your x's. And I just kept it as a fraction, but either or is fine. And I ended up getting y was 9. Now this is going to go off your graph, so we ran out of space, so you can just kind of copy what I have. But now we're going to go ahead and we're going to plot all of our points. So I've got our x-intercepts. Our vertex would be up here, but we didn't have space. And it is going to be dashed because it's just less than. And like I said, it would go like that. All right, so now we need to find a test point. So I'm going to use the test point 1, 0, because that's a pretty easy number to plug into the inequality. And so I'm going to plug in, use my original, and I'm going to plug in 0 for y, and I'm going to plug in 1 for x's. So once you go ahead and you substitute those in, you'll get 0 is less than, and then you have -4 plus 12. So 0 is less than 8. Well, that's true. So what that means is you're going to shade everything inside the parabola, and that's your solution. All right, let's do one more example. And for this example, if you notice here, look at the format. So notice that this is opening towards the y and it's pointing towards the equation. So it's okay to flip it, but if you flip it, watch your sign. Notice this is still open towards the y, and then it's pointing here. So I would suggest flipping, but if you flip it, you have to flip the sign. So just be careful there. All right, so now we got this, so I factored that out, and I got x times x minus 4. So set those each equal to 0, and I got an x-intercept of 0, 0, and I got another x-intercept as 4, 0. So I go ahead, plotted those, and then I found my x-axis of symmetry. So remember, it's negative b, so b is -4. So remember, it's a negative 4, which means positive 4, over 2 times 1. So I got 2, and that equals 2. Now that I know that, I can plug it in to find the vertex, and then I've got a vertex of -2, 4. So I went down here. And then you can just go ahead and you can use your 1A, 3A, 5A to graph the other points. And so from here, I went over 1, up 1, because A is 1. And then I went over 1, up 3, over 1, up 5. And then I just reflected it over here, up 3, over 1, up 5, and plotted your points there. So now this is going to be solid because it has the equal. And then now we just need to do a test point. So I can't do 0, 0, but I can do 1, 1. So we're going to substitute in your x and your y to your original, and I got that 1 is greater than or equal to -3, which is true. So that means you shade everything inside the parabola. And you're going to go ahead, you're going to complete the rest to find the solutions. It's just more of the same thing. Just make sure you solve for it. You find your vertex, any other important points such as your x-intercepts or y-intercept. And then you need to do a test point to see. If it's true, you shade where the test point is. If it's false, you shade everywhere else. And that is graphing quadratic inequalities.